Today we will discuss problems related to beta and gamma function. Problem based on beta and gamma function. In previous lectures, we have already discussed the properties and definition related to beta and gamma function. So we start the problem. So problem first, evaluate the integral 0 to infinity x raised to the power 4 into e raised to the power minus x into dx. So when we do the solution of this integral, so directly we use the definition of gamma function. So we write down this as given that integral 0 to infinity, we write down this as e raised to the power minus x raised to the power 4 into dx. So we write down by using definition of gamma function. So we use the definition of gamma function. Gamma function definition says that gamma n is equal to integral 0 to infinity e raised to the power minus x raised to the power n minus 1 into dx. So we compare the given integral by the definition of gamma function. So we see that e raised to the power minus x, e raised to the power minus x, same. Here we have a x raised to the power n minus 1. Here we have x raised to the power 4. So now we need to write down this x raised to the power of 4 as n minus 1. So because we write down the gamma n. So we write the above integral zero to infinity e raised to the power minus x raised to the power 5 minus 1 into dx. So 5 minus 1 equal to 5 minus 1 into dx. So this we see that the x raised to the power 5 minus 1, here x to the power n minus 1. So this integral is equal to gamma 5. So gamma n. So gamma n on the basis of that. This integral equal to the gamma 5. So on the basis of this n. Gamma 5. So what is the value of gamma 5? So we have a relation between beta and gamma relation. So we can write down that gamma n plus 1. We write down that gamma n plus 1 is equal to factorial n. So we know that the relation of, we have already proved this relation. So this gives us the factorial 4. What is the value of factorial 4? Equal to 24. So this is our answer. So this is the first question. So we have solved related to that. Now we move to the further questions. Further questions related to beta and gamma function. And so question number 2, evaluate the integral integral 0 to infinity e raised to the power minus 4x x raised to the 5 by 2 power 5 by 2 into dx. So now we do the solution of this integral. So we write down that given that integral 0 to infinity e raised to the power minus 4x x raised to the power 5 by 2 into dx. So we know that, we remember all the definitions related to gamma function when we are solving the problem related to gamma, and when we solve the problem related to beta, so we remember also. So we know that the if integral given in this form 0 to infinity e raised to the power minus ax x raised to the power n minus 1 into dx. So this is equal to gamma n upon a raised to the power n. So here this integral is given into this form. So now first we need to write this 5 by 2 in this n minus 1 form. So we can write down this integral 0 to infinity e raised to the power minus 4x into x raised to the power 7 by 2 minus 1 into dx. 7 by 2 minus 1 means 5 by 2. Now the value of this integral by using this definition gives us gamma 7 by 2 upon a. What is a? A is 4 when we compare this a to this a. So this is 4 here when we take this a. So a is 4, 4 raised to the power n. So 4 raised to the power n, what is n here? N is 7 by 2. So now we simplify this. So we also know that how to calculate the gamma 7 by 2. So we know that 3 5 by 2, 3 by 2, 1 by 2 into root 5 upon 4. 4 you can write down 4 2 to the square or upon 7 by 2. So this can be written as 5 by 2, 3 by 2, 1 by 2 into root pi upon 2 raised to the power 7. Okay, so 2 to 2 cancel. Now 5 3 ja 15. 15 into root pi upon. So 2 raised to the power 7 here and 2 into 2 into 2, 2 raised to the power 3 here. So this can be written 2 raised to the power 10. So 2 raised to the power 10. So this equal to 15 into root pi. So 2 raised to the power 10 is equal to 2 to the 4 to the 8 to the 16, 32, 64, 64 to the 128, 256, 256 means 512 and 1024. So 1024. So this is our answer. Okay, so this is our answer. Now we take another question related to that. So we have one more question. So integral 0 to infinity e raised to the power minus x cube, e raised to the power minus x cube into root x into dx. We write down evaluate. So we also need to evaluate this. So this is e raised to the power minus x cube, because in the formula we have only e raised to the power x. So we remember the formula of gamma function. So now when we make this integral into the form of gamma function, so we put x cube equal to t. So we need to make this function into this form, x raised to the power n minus 1 into dx. So we make this function into this form. So because we make this equal to gamma n. So now for solving this, put x cube is equal to t. So we see that 3x square into dx is equal to dt. So dx is equal to dt upon 3x square. dt upon 3x square. So what is the value of x here? So the value of x is t raised to the power 1 by 3. So now we put the value of x here also. So this gives us dt upon t raised to the power 2 by 3. So t raised to the power 2 by 3. Okay. Now when we talk about the limits, so when we put x equal to 0, so put x equal to 0. So this gives us 0 is equal to t, means t is equal to 0. And when we put x is equal to infinity upper limit, so infinity is equal to t, so means t equal to infinity. So the limits are remains unchanged. 0 to infinity. Now we write down that integral into the form of t. So integral 0 to infinity e raised to the power minus t into root x, into root x. So when we put x is equal to t raised to the power 1 by 3. So we put it x equal to t raised to the power 1 by 3 and whole to the power 1 by 2, because we have taken root x into dx. So what is the dx? The dx we have calculated in the form of t is dt upon 3 raised to the 3 into t raised to the power 2 by 3. So now we simplify this. So we write down this integral 0 to infinity e raised to the power minus t, and this gives us t raised to the power 1 by 6 into 1 by 3 we taken outside from the integral. This is the constant value into t raised to the power minus 2 by 3 we taken into the numerator, and into dt. So when base is same, so we add the power. So 1 by 6 minus 2 by 3. So we take 6 LCM. So 6 1 or 3 2 ja 6 or 2 2 ja 4. So this gives us minus 3 by 6 means minus 1 by 2. So we simplify this. So this can be written as 1 by 3 integral 0 to infinity e raised to the power minus t and t raised to the power minus 1 by 2 into dt. T raised to the power minus 1 by 2 into dt. So how to write this minus 1 by 2 power into the form of n minus 1? So we write down this power minus 1 by 2 into the form of n minus 1. So can we write this as in 1 by 3 integral 0 to infinity e raised to the power minus t, t raised to the power 1 by 2 minus 1, 1 by 2 minus 1 into dt. So using definition of gamma function, using definition of gamma. So when we use the definition of gamma, so this integral is equal to gamma 1 by 2. So this integral is equal to gamma 1 by 2. So gamma half. What is the value of gamma half? Is root pi. So we have solved means two. So this is our answer. So we take other problems related to beta function. So we start the questions related to beta function. So evaluate integral 0 to 1 x raised to the power 5 into 1 minus x raised to the power 2 into dx. Now for this we remember the definition of beta. By definition of beta, so beta mn is equal to integral 0 to infinity, 0 to 1, beta mn equal to 0 to 1 x raised to the power m minus 1 into 1 minus x raised to the power n minus 1 into dx. So we need to write this integral. So when we do the solution, so we write this integral into definition form. So we write down x raised to the power 6 minus 1 into 1 minus x raised to the power 3 minus 1 into dx. So this integral is equal to beta 6 into 3. So we write down this mn. So this here is m, here is n. So that's why we write down a beta mn. So similarly, this is m or this is n. So we write down 6 into 3. So when we use the relation between beta and gamma function, so beta 6 3 is equal to gamma 6 gamma 3 upon gamma 6 plus 3. So remember this relation beta mn is equal to gamma m gamma n upon gamma m plus m. So what is the value of gamma 6? Gamma 6 value is factorial 5. Gamma 3 value is factorial 2 upon gamma 9. So gamma 9 value is factorial 8. So when we simplify this, factorial 5 into 2 upon 8 into 7 into 6 into factorial 5. So factorial 5 to factorial 5 cancelled. 2 4 are 8. So this gives us 1 upon 7, 7 6 are 42. 42 into 4. So this gives us 1 upon 168. So 1 upon 168. So this is our answer. Okay, so the problem basically based on the direct definition. So we do the practice of the questions, then we can solve easily. Now we take more problems related to other properties of beta function and gamma function. So we have the question related to other properties. So evaluate the integral integral 0 to infinity x raised to the power 4 into 1 plus x raised to the power 5 upon 1 plus x raised to the power 15 into dx. So we remember the properties. So we also have one relation with beta mn equal to integral 0 to infinity x raised to the power m minus 1 upon 1 plus x raised to the power m plus n into dx. So we follow this relation. Okay, so we write down this integral into this form. So we write down this integral 0 to infinity x raised to the power 4 plus x raised to the power 9 upon 1 plus x raised to the power 15 into dx. So this equal to, we write down the integral in separate form, x raised to the power 4 upon 1 plus x raised to the power 15 into dx, plus second integral we can write down 0 to infinity x raised to the power 9 upon 1 plus x raised to the power 15 into dx. Now we follow the above formula. So we write down this as x raised to the power 5 minus 1 upon 1 plus x raised to the power m plus n. So m here we consider as 5. So m plus n means we can write down 5 plus 10. So these two values remain same. So this is m remains same. Okay, into dx. Plus similarly, if we write down for this also, so we write down as 10 minus 1 upon 1 plus x raised to the power 10 plus 5 into dx. So these two values are remain same, that is in the place of m here. So we see that, so this is equal to 510 beta 510 plus this integral equal to beta 10 into 5. Now we know that the relation beta mn is equal to beta nm. So beta mn equal to beta nm. So this can be written as beta 510 plus we can write down this also as beta 5 into 10. So this equal to twice of beta 5 comma 10. So this equal to twice of 5 comma 10 means gamma 5 gamma 10 upon gamma 5 plus 10. So this equal to 2 into factorial 4 into factorial 9 upon gamma 15 means factorial 14. So this you can write down factorial 14. So you can simplify this. So 2 into 24 into factorial 9 upon 14, 13, 12, 11, 10 into 9 factorial. So 9 factorial to 9 factorial cancel. 12 2 ja 24. 2 5 ja 10. 2 7 ja 14. So we write down the numerator is 1 upon 5 into 7 into 11 into 13. So this will equal to 1 upon 5005.